Myself, Rajendra S. Karade. My qualification is MSc Chemistry B.Ed and experience is of 28 years. Now, today we are going to discuss about the term that is concentration quotient, which is also called as reaction quotient. Now here first we'll discuss about the definition. Concentration quotient is nothing but the concentration ratio that is ratio of product of molar concentration of the products and product of molar concentration of the reactant. In the balanced chemical reaction, at any stage of chemical reaction, and at a constant temperature. Concentration quotient, which is also called as reaction quotient, is nothing but the concentration ratio, that is ratio between product of molar concentration of product and product of molar concentration of reactant in the balanced chemical equation and at any stage of chemical reaction at a constant temperature, or ratio, concentration ratio that is ratio between product of molar concentration of the product and product of molar concentration of the reactants with each concentration term raised to power equal to stoichiometric coefficient of the in the balanced chemical equation at any stage of chemical reaction and at a constant temperature. Concentration quotient or reaction quotient is also defined as the concentration ratio, that is ratio between product of molar concentration of product and product of molar concentration of reactant, with each concentration term raised to power equal to the stoichiometric coefficient in the balanced chemical equation or balanced chemical reaction at any stage of chemical reaction and at a constant temperature. Now, it is denoted by or it is represented by QC, that is molar concentration or QP, that is partial pressure. Now let us consider a reaction, that is AA plus BB gives CC plus DD. Here QC is equal to concentration of C raised to the power C, concentration of D raised to the power D upon concentration of A to the power A, concentration of B to the power B. In a similar manner, QP is equal to PC raised to the power C into PD raised to the power D upon PA raised to the power A into PB raised to the power B. Now here at equilibrium, concentration quotient is equal to equilibrium constant, that is Q is equal to K. Now here symbol for state symbols for states, that is solid, liquid and gas, are ignored in the expression of equilibrium constant. Otherwise, it is very essential. Second, subscript EQ is used for expressing the equilibrium constant is also omitted. Equilibrium concentration is also omitted in the expression of equilibrium constant. This is because it is taken for granted that the concentration in the expression are equilibrium value. Now here write down units of equilibrium constant. Now the unit of equilibrium constant Kc and or Kp in terms of molar concentration or partial pressure depend upon number of moles of reactants and products involved in the balanced chemical reaction. Now, the unit of equilibrium constant Kc or Kp is calculated by using the difference between number of moles in the numerator and denominator. In the expression of equilibrium constant, now here consider the case 1. It has no unit. It has no unit means equilibrium constant Kc or Kp has no unit when number of moles of product is equal to the total number of is equal to the total number of moles of reactants. That means here write down H2 gas plus I2 gas gives twice HI gas. That means here Kc is equal to concentration of HI upon concentration of H2 into concentration of I2. That means here Kc is equal to mole per liter square upon mole per liter into moles per liter, that is mole per liter square upon this gets cancelled, that means here no unit. Now this can also be calculated as delta n is equal to n2 minus n1. That means here n2 is the number of moles of product and n1 is the number of moles of gaseous reactant. That means here write down 2 minus 1 plus 1, that is 0. That means here Kc is equal to mole per liter raised to the power delta n, that is mole per liter raised to the power 0, that means again here no unit. Then next second case, here write down it has a unit when total number of moles of product is not equal to the total number of moles of reactants. Now here example, N2 gas plus thrice H2 gas gives twice NH3 gas. Here Kc is equal to concentration of NH3 upon concentration of N2 NH3 square, here N2 H2 cube. That means here Kc is equal to mole per liter raised to the power 2 upon mole per liter into mole per liter raised to the power 3. That means here this gets cancelled, here 1, that is 1 upon mole per liter raised to the power minus 2. That means here mole raised to the power minus 2, that is mole raised to the power 2 and liter raised to the power minus 2. Now that is 1 upon mole raised to the power 2 and liter raised to the power minus 2, that is in a similar manner that can also be calculated by calculating the value of delta n, that is delta n is equal to n2 minus n1. That means n2 is the number of moles of gaseous product and n1 is the number of moles of gaseous reactant. Here number of moles of gaseous product are 2 minus number of moles of this reactant is 1 and that of 3. That is 1 plus 3 is equal to minus 2 mole. That means here delta n Kc is equal to mole per liter raised to the power delta n. That means mole per liter minus 2, that is mole raised to the power minus 2 and liter raised to the power 2. Now here keep in mind the most important point is that Kp is equal to Kc RT raised to the power delta n. Now here Kp is the equilibrium constant in terms of partial pressure. Kc is the equilibrium constant in terms of molar concentration. R is gas constant, is the temperature in Kelvin, and delta n is the number of moles of gaseous product minus number of moles of gaseous reactant. That means here delta n is equal to n2 minus n1. Now we write down case 1. If delta n is positive, delta n is positive means n2 is greater than n1. Delta n is positive, that means this is positive. That is Kc into RT is equal to Kp, meaning is that then Kp is greater than Kc. Case 2, if delta n is negative, that means here n2 is less than n1. Delta n is negative means this term is negative. That means here Kc upon RT, Kc upon RT. That means here then Kp is less than Kc. And case 3, if delta n is 0, then n2 is equal to n1, and then Kp is equal to Kc. Now let us consider an example here. Twice NH3 gas gives N2 gas plus thrice H2 gas. Here delta N is equal to N2 minus N1. That means 1 mole, 3 mole, that is 1 plus 3, and this is minus 2, that means 2 mole. Now here delta N is positive, that means for this reaction Kp is greater than Kc. In a similar manner, let us consider second example. N2 gas plus thrice H2 gas gives twice NH3 gas. Here delta N is equal to N2 minus N1. That means 2 minus 1 plus 3 equal to minus 2 mole. That means here delta N is negative. Delta N is negative, meaning is that Kp is less than Kc. Third, H2 gas plus I2 gas gives twice HI gas. Here delta N is equal to N2 minus N1. That means 2 minus 1 plus 1, that is equal to 0. That means here apply this case, and here Kp is equal to Kc. That means in this way you can find out the relationship between Kp and Kc, whether Kp is greater than Kc or Kp is less than Kc, or Kp is equal to Kc by considering the sign of delta N, whether it is positive, negative or 0, without calculating the value.